Okay, the last few days we've been working on trig identities and simplifying using trig identities. Well, today we're going to use trig identities to verify trig identities. Okay, so let me explain to you what that means, and you can fill this in. To verify an identity, means to prove that both sides of the equation are equal for all values of the variable for which both sides are defined. So basically what that means is you're given the answer, so to speak, okay? In other words, it's telling you that tangent squared x plus 1 over 1 minus sine squared x is equal to secant to the 4th power x, okay? So before you were doing this right here. You weren't given an equal something. You were given that right there and told to simplify, okay? Now it's giving you what it should come out to be, but you've got to prove it, okay? So you've got to, so here you know where you're going. Before, you just simplified and you just kind of had to just work with it. But here we know that we want to end up with secant to the 4th power x. Okay, so we need to get our trig identities out. Okay, these things. And we're going to be using the Pythagorean identities on this first one. If you'll notice all those squares, tangent squared, sine squared. So we're going to start, you usually want to start with the more complicated side and try to work it until you get the least complicated side, okay? So we've got tangent squared x plus 1 over 1 minus sine squared x, okay? So look at your Pythagorean identities. I think I see some things that will help us here. I see tangent squared x plus 1 or tangent squared theta plus 1, and what is that equal to? Y'all need this. You need to have it handy and ready to pull out. Because we're going to be using these quite a bit. I want to be able to ask you, okay, what is this? And you be able to answer me. All right. So, Ashley, you got yours ready over there. So, do you see tangent squared theta plus 1 or x or whatever? All right. What is it equal to? Secant squared x. So, that's looks like we're in the right direction, right? Because we want to end up with secant to the 4th x. So this is equal to secant squared x over, now do you see 1 minus sine squared x on your Pythagorean identities? Yep, and what is it equal to? Cosine squared x. Okay. Now, what do we know about cosine's reciprocal? What's the reciprocal of cosine? 1 over secant, which secant's what we want, right? So let's rewrite cosine squared x as 1 over secant squared x. Now, when you divide by a fraction, you flip the second one and multiply. So we have secant squared x over 1 times, flip the second one, secant squared x over 1, which gives us what? So basically we end up with secant squared x times secant squared x, right? Which would be, and that's what we wanted. So basically, we just proved our identity. So when I grade these, I'm going to be looking at your proof. I'm not just going to look for this because that's given to you. I'm going to be looking for the proof and make sure your proof makes sense. And there may be other ways to do it. Okay, 1b, verify that 2 minus cosine squared x equals 1 plus sine squared x. Okay, you can really start with either side, but I'm going to start with the 2 minus cosine squared x. So somehow I've got to get it to this. Well, if I look at my Pythagorean identities, I have a Pythagorean identity for cosine squared x that has sine squared x in it. Right here it says cosine squared theta, or x, whatever, is equal to 1 minus sine squared theta. So I can replace cosine squared x with 1 minus sine squared x. So I have 2 minus 1 minus sine squared x. Okay, so I replace this with this. Okay, now I need to distribute my negative right here. So I have 2 minus 1 plus sine squared x. Now what's 2 minus 1?
Sine squared x.
It's 1. And that's what I needed to prove. So I've just proved it using my identities. All right, so those are some basic ones. So now let's move on to example 2. Example 2, we're going to be combining fractions to verify these. All right, so I have negative 2 cotangent x equals sine x over 1 plus cosine x minus sine x over 1 minus cosine x. So you really usually want to start with the more complicated side and try to get it to this. Because it would be awfully hard to take this and get it to this. You see what I'm saying? It's doable, but pretty difficult. So start with the more complicated side. So it doesn't matter if you start on the left side of the equals or the right side. Okay, so start with the more complicated side. All right, so we're going to take this side and try to work it till we get negative 2 cotangent x. So we have sine x over 1 plus cosine x minus sine x over 1 minus cosine x. So we want to take that and try to simplify it till we get negative 2 cotangent x. Now this one's going to be pretty long, the way I did it. Okay, so I have 2 fractions here that I need to combine somehow. Well, to combine fractions, you've got to have a what? A common denominator. Well, I have a 1 plus cosine x here and a 1 minus cosine x here. That's two totally different things. So they're both going to have to be in my common denominator. Okay, so I'm going to have 2 fractions. And my common denominator is going to be 1 plus cosine x times 1 minus cosine x. 1 plus cosine x, 1 minus cosine x. So over here, I have the 1 plus cosine x in my denominator, but I don't have the 1 minus, which means I would have to multiply by 1 minus cosine x. So I've got to do the same to the top. So sine x times 1 minus cosine x. So basically, you're multiplying this by this denominator. Does that make sense? And then over here in this fraction, I have the 1 minus, but not the 1 plus. So I'm going to need to multiply by the 1 plus. So it'd be sine x times 1 plus cosine x.
You forgot to put your x between sine and.
Thank you. All right, so now, right now on the top, I'm just going to rewrite my numerator. So I have sine x. I'm not going to distribute or anything right now. Times 1 minus cosine x minus sine x times 1 plus cosine x. Okay, and we're subtracting that whole thing, so that's why I put those brackets around that whole thing. Now, I see something here. These are conjugates of each other. Do you remember what conjugates are? A conjugate is when you have a plus and a minus, but otherwise it's the same. Okay? And what it'll do is when you multiply it together, the two middle terms will cancel out. So you'll end up with the difference of squares. So I think we probably need to go ahead and multiply this together. So we would have 1 times 1, which is 1. Then we would have outside negative cosine x, inside positive cosine x. So those two would cancel each other out, right? So then we multiply the last terms. Cosine x times negative cosine x would be negative cosine what? Squared x. Good.
So those
So,
canceled out. The cosine
1 minus cosine squared. When you do the middle terms, but then you have to look, when you do FOIL, 1 times 1 is 1. Outside, 1 times negative cosine x is negative cosine x. Inside, 1 times cosine x is positive cosine x. Last terms, cosine x times negative cosine x. So these cancel out, and you're left with 1 minus cosine squared x.
Push over.
This way?
Yeah.
All right, so this little, let me go back over here. This right here is just some side work, okay? And scratch work there. All right. So now I'm going to go ahead and distribute here and here. All right, and then here in a second, I'm going to go ahead and simplify 1 minus cosine squared x. Okay, if you look at your Pythagorean identities, that's going to be sine squared. So when we rewrite it in a minute, we'll change that to sine squared. Okay, so sine x times 1 is sine x. Sine x times negative cosine x is negative sine x cosine x. Okay, minus, I'm going to put this in parentheses because you have to distribute the negative. Sine x times 1 is sine x. Sine x times, oops, I left the x out right there too, Cole. You didn't catch that one. Sine x times cosine x is positive sine x cosine x. All over, now here's where I'm going to change my 1 minus cosine squared x to sine squared x. So now I've got a bunch of stuff in the numerator. So I want to distribute this negative and then combine any like terms that I have. So I have sine x minus sine x cosine x minus sine x minus sine x cosine x, all over sine squared x. Y'all with me? This is long. And basically we're doing basic algebra, but it looks a lot harder because we have all these sines and cosines and stuff in it. All right, so let's combine like terms on the top. I've got a sine x here and a negative sine x here. I can cancel those out, can't I? Then I have a negative sine x cosine x and a negative sine x cosine x. Those are like terms. So if I add them together, I would get negative 2 sine x cosine x, right?
It wouldn't be that squared. It'd be just 2 in front.
because we're just combining like terms. It would be like having negative x plus a negative x, or negative x minus x. It would be negative 2x. Okay, it's the same idea. You just got it's just your x is sine x, cosine x. It's all, okay, it's a little more complicated looking. All right, so I've got negative 2 sine x cosine x. Now let's don't forget our denominator over what? Sine squared x. So I could rewrite this to make it a little more clear, because I'm fixing to do some canceling out. Some simplifying. Sine squared x is really sine x times sine x, right? And put a times or whatever. So these are going to cancel out. Now, what's cosine x over sine x? That's a quotient identity.
Tangent.
Is it tangent or cotangent? Go look at your paper. You got them right here at the top. Cosine over sine.
Oh, that's cotangent.
It's cotangent. So I have negative 2 times cotangent x. And is that what we wanted? Is that what we have at the top? Yep. So what'd y'all think about that one?
Too hard.
Too hard?
Yeah.
No. No, it's not. You can do it. All right, so let's look at 2b. Verify 1 plus cosine x over sine x plus sine x over 1 plus cosine x is equal to 2 cosecant x. Okay, too bad that wasn't multiplying, then we could cancel those out, but it's not multiplying. So we got, which side should we start with? Which side should we try to simplify?
Fractions.
We want to start with this side. Start with the more complicated looking side. 1 plus cosine x over sine x. It's a lot easier to go from complicated to simplified than it is from simplified to complicated. Plus sine x, I'm just rewriting right now, 1 plus cosine x. So I have two fractions here. How do I combine fractions? What do I have to have? A common denominator. Well, I got a sine x here and a 1 plus cosine x here. So that's going to be my common denominator. Sine x times 1 plus cosine x. Plus sine x, 1 plus cosine x. So over here in the numerator, I've got 1 plus cosine x. And in the denominator, I have sine x. Well, in my new denominator, I have the sine x, but not the 1 plus cosine x. So that means I'm going to have to multiply 1 plus cosine x times 1 plus cosine x. Because I would need to multiply sine x times 1 plus cosine x to get this denominator. So I've got to multiply the numerator by 1 plus cosine x also. That's just equivalent fractions. Huh?
Why don't you just add them across?
What do you mean?
It's addition, so the denominator is the
You got to have common denominators. And then you got to find your equivalent fractions. That's what we're doing right now, is finding equivalent fractions. Because,
yeah.
okay. All right. So now on this one, I have the 1 plus cosine x, but not the sine x. So that means I need to multiply the numerator and denominator by sine x to get that denominator. In other words, I had to multiply this times sine x to get that. So I got to multiply sine x times sine x to keep it equivalent. Now I can combine my numerators since I have the same denominator. Now look at this thing right here. Let me see. I'm trying to remember if I went ahead and combined them. Okay. Here, let's go ahead and FOIL it. Okay, now these are not conjugates, so the middle is not going to cancel out. Okay, do y'all want to kind of go out to the side and do that so you can see it, or can we do it all right here? Okay, well, let's try it. I think y'all can handle it. All right, 1 times 1 is 1, right? Okay, now do outside. Outside is 1 times cosine x. Inside is 1 times cosine x. So we have cosine x plus cosine x, which would be what? 2 cosine x, right? Because just like if it was x plus x, that would be 2x. So cosine x plus cosine x is 2 cosine x. All right, then cosine x times cosine x is cosine squared x. Okay? All right. Now let's do this numerator. We need to combine these two. What's sine x times sine x? Sine squared x. All over sine x, 1 plus cosine x. Right now, I would not combine, I would not distribute right now, because I'm hoping that something will cancel out. All right, now, in the numerator, I don't see any like terms to combine, but I see 2 squared terms. And I'm seeing a Pythagorean identity. Look at cosine squared x plus sine squared x. Look at your Pythagorean identities. What is that the same as?
1.
1. So this little thing right here can be simplified to just 1. Now I can combine 1 plus 1, which is 1 plus 1 is 2. All right, plus 2 cosine x over sine x times 1 plus cosine x. Now I can see what I need to do. Can y'all see what we need to do in the numerator? What do both of those terms have in common?
Cosine x.
No, in the numerator. What do both of those terms have in common? 2, 2. Let's factor out a 2, and guess what's going to happen? Can you see it?
1 plus cosine.
Yeah, there you go. So factor out a 2, and you have 1 plus cosine x over sine x, 1 plus cosine x. See, that's why I didn't distribute right away, because that worked out. Those two now cancel. So I have 2 over sine x. But that's not what I'm looking for. I'm looking for 2 cosecant x. Well, I can see that right there. 2 over sine x is the same as 2 over 1 times 1 over sine x.
It's 2 cosecant x.
So 1 over sine x is cosecant x. So you have 2 cosecant x. So it checked out. Okay. Are your minds blown yet? Okay. Let's move on. Now, example 3, you're going to verify a trig identity by multiplying. So, which side do you think we want to start with? I'd start with the left, because it's a lot easier to take a fraction and figure out a way to not make it a fraction than it is to take these things and try to make fractions out of them. Okay, so I would start with this side. So we have sine x over secant x minus 1. Okay, well, it's not 2 fractions to combine. It's just 1 fraction. I don't see anything I can simplify. That's not a secant squared x, so I can't use a Pythagorean identity. So, one thing you can do is if you have a situation like this where you have a binomial in the denominator, you can try multiplying by its conjugate. Okay? But if you multiply the denominator by the conjugate, you're going to multiply the numerator by the conjugate. So let's try that. Let's multiply by secant x plus 1 over secant x plus 1. And I can do that because secant x plus 1 over secant x plus 1 is 1. When you multiply by 1, you're not changing the identity of it. It's still going to be the same, different form. So in the numerator, I'd have sine x times secant x plus 1. Let's just leave it like that for right now. Then in the denominator, now I'm going to do my FOIL, but my middle terms are going to cancel out. So basically, I'm just going to square the first and square the last. That's a shortcut, but you have to be careful because it only works with conjugates. I see people all the time trying to square two binomials and they leave out the middle part because they just square the first and the last. That'll work with conjugates, but not with anything else. So secant x times secant x is secant squared x. Negative 1 times positive 1 is negative 1.
Square.
Negative 1, you multiply your last. Negative 1 times positive 1 is negative 1. Okay. So, hold on a second. Let me look at something here. All right, secant squared x minus 1. I see that in the Pythagorean identities. Tangent squared, right here. Secant squared theta minus 1 is tangent squared theta. It comes from this identity. But remember, we rewrote them. Makes it a lot, don't y'all find it a lot easier to have them all written rather than just using the basic 3 and then trying to figure it out? You could see that secant squared x minus 1 would be tangent squared x, or theta. But if you have them all written like this, it's a lot quicker. All right, so this would be tangent squared x. Now what you want to do is, we have a sign up here on the top. Well, I can rewrite tangent squared x with sines and cosines, right? Or with sine and cosine. So tangent of x is equal to what? Sine over cosine. Well, if you did sine over cosine times sine over cosine, that's sine squared over cosine squared, right? So this would be sine x. I'm just going to leave the numerator alone for right now. And then this would be sine squared x over cosine squared x. So now I have a fraction, so I can basically divide fractions. So when I divide fractions, I'm going to flip this one and multiply. So I have sine x times secant x plus 1 over 1 times cosine squared x sine squared x. Okay, do you see what I just did? So since I'm multiplying, I have a sine x here and a sine squared x here, so I can cancel out one sine x. So that's gone, and that is now sine x. So now I have cosine squared x times secant x plus 1 over just sine x. Okay, so do you have any ideas for where we're headed here? Wait just a second. Okay, it looks like, let's go ahead and distribute this right here, because when I distribute, well, you'll see what happens. All right. So we have a cosine squared x times secant x plus cosine squared x all over sine of x. Okay, now I have this little multiplication right here, right? So I can change, what's the reciprocal of secant? Cosine. So that looks like something maybe I need to do. So I would have cosine squared x times 1 over cosine x plus cosine squared x. So one of these, this would be over 1. So that will cancel out. And what do I have here? Just cosine x. So I have cosine x plus cosine squared x over sine x. I skipped too many steps in my work. Okay. Now we want to take this and separate it. We have a single denominator, but we have 2 terms on the top. So we want to take each one of the terms on the top and write it over the common denominator. So instead of combining fractions, we're kind of taking it apart. So we have cosine x over sine x plus cosine squared x over sine x. So what's cosine x over cosine x?
Cosine x over sine x.
I mean over sine x. Yeah. All right. Something's bugging me here, though. I want to rewrite this right here. Let's do cosine x over sine x plus, and I'm going to do this. See what I did? I took the cosine squared x and wrote it like this. That makes it a little clearer. All right, so you said cosine x over sine x is equal to what?
Cotangent.
Cotangent. Okay, we're getting there. All right, plus, what's cosine x over cosine x? We got another cosine over sine right here.
I mean cosine over sine is cotangent.
So another cotangent x, and then just the cosine x. So this was cotangent times cosine. Okay, now what I want you to do is I want you to see if you can figure out 3b right now. You can do it, can't you, Cole? Yeah, you can. Which side are you going to start with?